Welcome back. In this video, we are going to be talking about wiring multiple LEDs. So here's where we start to introduce a little bit of complexity, make our circuits look a little bit cooler, etc. So we're really going to take things to the next level. So kind of like our previous videos, I'm going to have a little bit of a slideshow to talk about the key concepts that we're going to be going over. And then afterwards, we're going to actually look at how to wire multiple LEDs in Tinkercad. So let's get started. Okay, so before we actually talk about wiring multiple LEDs and, start like messing around with wires and stuff, let's kind of take a moment to do some brainstorming. So let's think about some ideas. So the first one I've got here is we take multiple different LEDs and basically we chain them together, kind of like old-fashioned Christmas lights. So that's option one, right? Option two is to take all the LEDs and basically route their wires into the battery itself. So all of the positive ends of the LED go into the positive end of the battery, and all the negative ends of the LED go into the negative end of the battery. Option three is, well, we could technically use multiple batteries, so one battery per LED. Or option four, we could just forget about all of this and just embrace the one LED life. One light's enough, right? In all seriousness, we're going to explore the first two ideas. Now, something to keep in mind is the goal with wiring multiple LEDs is we want multiple LEDs to turn on at once, right? So, in other words, the moment we supply power, they're all going to turn on at the same time. The moment you cut power, they're all going to turn off at the same time. All right, so let's explore these ideas. So first one, the specific name for it is called wiring in series. So in a series circuit, all of the LEDs are arranged in a single path. This means that the current flows from a single path. So it starts from the battery, then goes to the first LED. Then it goes to the second LED, then it goes to the third LED, then the fourth one, the fifth one, etc. All right? So the current flow is going to be the same across all of the LEDs, but the voltage is actually going to be different. So the total voltage within the circuit, so across all the LEDs, is equal to the sum of the individual voltages that are going into the LEDs. Basically, what that means is the voltage is basically split up. So this is just a theoretical example, but if you had two LEDs and you had a 9-volt battery, each of the LEDs would get 4.5 volts. Now, something to keep in mind, and this is kind of the classic example for those of you who've maybe hung up Christmas lights before, is when one LED loses power, all of the LEDs are going to lose power. So, kind of similar to the way old Christmas lights work. The next option is wiring in parallel. So in a parallel circuit, all of the LEDs are going to be arranged in what are called branches. This means that the voltage across all the LEDs is going to be the same, but it's actually the current that gets split up. So if you have, let's use a classic example, 20 milliamps total current, 10 is going to go to one LED, while 10 is going to go on the other LED. So now what we're going to do is basically start wiring, two LEDs. One of them is going to be in series and the other one is going to be in parallel. So let's get started. Let's head over to my Tinkercad dashboard. Let's go ahead and create a new circuit. Let's call this 2.4 circuit. Okay, so first thing we're going to do is go ahead and start wiring in series. So I've got my battery here. Now, let's go ahead and actually grab two LEDs and the resistors that we need for those. So we're going to have the first one. Let's keep it in red. Again, feel free to explore with colors. Whatever you love is up to you. Red, blue. Let's grab the resistors. Resistor. We're going to connect it right there. Resistor. Connect it right there. Okay, so this is kind of like the baseline setup of exactly what we need. Okay, so one thing that I want to do before we continue is just change the resistance on these to 450 ohms, since we know these are the resistors that we associate with current. And remember, the current is the same, so you're going to want to have to make sure that you're resisting the same amount of current as before as well, even in the one LED case. Okay, let me just see if I can move these up. By the way, if you want to do the highlight feature, because by default, if you move your mouse around, you're going to move your window. But if you just want to highlight a bunch of different components, if you want to highlight a bunch of different components, hold down the Shift key, and there you go. I'm just going to move this up a little bit. Okay. Well, the first thing we're going to do is let's wire our negative side. So the first thing that's going to happen is we're going to take a negative wire, and we're going to feed it into our cathode of our first LED. Now the next thing we're going to do is literally take the cathode of this LED and plug it directly into the next one. So you see we kind of have a chain happening where it starts from this battery, goes up to this LED, then goes from this LED's wire to the next one, etc. And we're quite literally going to do the same thing with the anode sides. So this time going straight into our resistor, of course. So get something going like that. I actually kind of want to angle the wire a little bit so it's more clear. Yeah, there we go. By the way, if you ever want to straighten out your wires, you can just move this around. This is kind of like the image tool on Google Slides, if you've ever worked with that, where you want to center an image on your presentation. It's the same idea. And then we're just going to get another branch going off here. And then, yeah, let's just line it up a little bit. Okay, perfect. So now this, in theory, should allow us to light up. So, again, let's just go over what's exactly happening here, right? So we've got this wire, this negative side of the battery that's going into the cathode of this LED. Then we take a wire from this cathode and go to the next LED. Now, the same idea applies to the anode side, although we're just connecting it to a resistor because, remember from before, a resistor is just a wire, right? So we go from the positive end up to the resistor here, and from the resistor to the next resistor. Basically, we're creating a chain. So let's go ahead and start the simulation. And there we go. We got our two LEDs lit up. You can tell it's at a pretty high brightness just based on the visual here. And yeah, we got two LEDs. Pretty cool. All right, now let's explore that alternate method, right? That wiring in parallel method. So let's go ahead and get another 9-volt battery going here. Okay, just gonna, no, that's that one, and then, flipped it too much. Okay, all right. So the main idea of this one is we're gonna have two LEDs that form, and each LED is going to form its own branch, right? So what I like to do, just to see the difference here, and let's just change this to all real quick. Yeah, there we go. Is I like to put an LED, but I just like to change its orientation. So I'm gonna put this LED in this orientation like this, just so you can really visualize the branch, and you'll see what I mean in a second. Now let's just duplicate that. Yeah, you can Control-C and Control-V just like a Word document in Tinkercad. It's very nice. Okay, let's get the resistors. Again, I'm just gonna flip this around. Let's move this over. Let's change this to 450 and not kilo ohms. That's an insane number, just regular ohms. We're gonna do the same thing for this side. Let's copy and paste this resistor. And I'm gonna flip the orientation of this real quick just so they're both lined up. Okay, let me just slide this down. I kind of want this to be lined up as nice as possible so you guys can really see the difference. Feel free to do the same optimizations on your computer at home. Perfect. Okay, so here's the idea, right? It's basically just going to route all the wires from the battery to the individual LEDs instead of having, sort of a chain. So let's start with the negative end, right? I'm going to start at the battery and feed the negative end of the battery into this red LED's cathode, right? Now I'm going to start at the battery again and put it into the blue LED's cathode. So you see how we kind of have two branches forming with this negative wire, right? Or from the negative end of the battery, rather. One is going to the left to the red LED. The other is going to the right with the blue LED. Now let's do the same thing with the anode side, or the positive end, rather. So I'm going to have one branch going in like that, which is great. And then, directly from the battery again, we're going to have another branch going off like that. Wonderful. Okay, so now this is wired in parallel. So again, let's look at the main differences, right? Let's get them close to each other. Let's see what's going on. So, right, on the series end, each wire goes into one. So this wire goes into the first LED, and then we take the wire from the first LED and connect it to the second LED. Same idea for the anode end. Here, however, the negative end of the battery is supplying power, or is being wired rather, to the first cathode, and then we use the negative end of the battery again to go to the second end. So notice the amount of connections coming from the battery. Here, there are only 2 connections going into the battery in the parallel circuit. Actually, let me add a label so it's easier to distinguish. So series, and then this is parallel. Wonderful. Okay, so yeah, once again, only 2 wires on this end, 2 on each, so 4 wires total. So if we go ahead and start the simulation, we see them all turn on, right? And notice that they're almost basically the exact same brightness. So now you might be wondering, like, okay, I told you guys that in series the voltage is distributed, but the current remains the same across all the components. And then in parallel, the voltage is distributed, but the current remains the same across all the the voltage is the same and the current is distributed. So actually, let me add that in. Series V is, So in series V is distributed, and then I is the same, and then in parallel, V is the same, and then V for voltage, right? And then I for current is distributed. So like those are some, technical distinctions, right? But like, what's like the physical thing that's like, okay, I know this is in series and this is in parallel? Well, the most obvious one, right, is the number of connections that are coming from the battery. That's basically going to be the main distinguisher here, right? If you can trace the wires of each LED to coming directly from a power source, and that applies for all of the LEDs, then it's in parallel. On the other hand, for series, if you trace an LED's wiring to come from another LED, then you know that you're in series. Now that's the first physical difference. There is another one. So what I'm going to do is start the simulation. Now notice all of them are lit up right now, right? What I'm going to do now is I'm going to unplug just one wire from each of the LEDs. So I'm going to unplug this wire from this guy. And I'm going to unplug, so that was the negative end connector from the red LED to the blue LED. And I'm going to disconnect this guy from over here. So if I run this, so immediately you'll notice that this red one disconnected, which is fine, and that makes sense. And this blue one stayed on. Now you might be wondering, wait a second, what's going on? I mean, they're the same. Now, the key difference that I want to show you here is notice where I disconnected the wires from, right? In the parallel circuit, the LED wire that I removed was from the power source. But from the series circuit, I didn't remove it from the power source, so this red LED could stay on, right? So a nice way to sort of think about what's going on here is think about where the power source is coming from. For this blue LED, it's missing an entire wire, so obviously it's not going to get power. But for the red one, it's still getting power from the battery, so we're all fine, right? And similarly on this end, well, we quite literally removed power from the red LED. We disconnected a wire coming from the battery, so it makes sense, right? The red LED won't turn on. It's quite literally missing a wire or a connection. But the blue LED will stay on because it has all of it. Now here's where things get interesting, right? Let's undo, and instead of now I'm going to remove this battery wire from the power source, right? Now let's level the playing field here. Let's do the same thing for the series circuit. So I am going to disconnect a wire connected to the power source. It's going to be this black one. So again, we've done the same thing across both sides, right? Here I disconnected a wire from the negative end of the battery, and here I also did disconnect a wire from the negative end of the battery, and notice what happens. None of these turn on, right? And that's really the main advantage to parallel wiring. See, I disconnected one wire from the power source, and the rest of them turned off. Here, I only disconnected one wire from the power source, but the other one still stayed on. And that's the key distinction. Now, let's go back to the case where I had removed this wire. Well, obviously this LED is going to turn off. But in fact, if I actually included another LED, that other LED is also going to turn off. And that's really where you start to see the Christmas light effect that I was alluding to earlier. So let's, not that. Let's highlight everything carefully. Shift it over. I don't know what's happening to that wire, but it's okay. We won't need it anyway. And what I'm going to do is I'm going to wire a third LED. So let's get a third LED going here. By the way, if your menu ever goes away like this, you can hit this arrow here and it comes back. So let's get an LED. Actually, I can just copy and paste. Okay, there we go. Let's change this guy to green. Okay. Now I'm going to, I don't want red. I'm going to connect the positive end of the LED to this guy right here. This terminal, cool. Switch to black, and I'm going to connect it to this LED. So notice, right, and I just wanted you to focus on the series end for now. Okay, so here's what's happened, right? Now I haven't actually removed anything from the power source, but I did in fact remove a wire that basically connected this LED to the next one. Watch what happens. Both of these are off. And so now, hopefully, that makes sort of the chain effect a little bit more clear. Or rather, I guess this is more of a domino effect, if you will, right? We disconnected one of the wires here, and so the rest of them don't get power. And that's really the main distinguisher, right? In parallel, I could remove one of these wires and restart the simulation, and, well, the other one would still stay on. But in a series circuit, you could see that removing one wire, just one wire, caused me to lose two of my LEDs. And again, it's because of that chain, or if you want to view it as a domino effect, it's because of that. So hopefully now you have a better idea of, the different ways we can wire multiple LEDs. Keep in mind that there's a reason why these two different methods exist. And it really has to do with the series versus parallel idea. I mean, think about having hundreds of thousands of LEDs. I mean, it's an insane number, but would you really want the voltage to be distributed? Or, if you got hundreds of thousands of LEDs, if one went out, I mean, the other 99,000 are going to go out, right? So, it's really up to you. I mean, series is obviously the simplest, right? You kind of just go from one LED to the next. Parallel gets a little more complicated in that you have to connect everything directly to your power source, but remember, it's up to you to weigh the pros and cons, especially when you're building a circuit. So I hope that gave you a solid introduction. Thanks so much for watching, and I look forward to seeing you in the next video where we talk about our first mini project.